Okay, guys, just answer your roll call. Roll number 1. Roll number 1, absent. Roll number 2. Roll number 2, absent. Roll number 3, absent. Roll number 4, absent. Roll number 5, absent. Roll number 6,
Present, sir.
roll number 8, number 8, present. Roll number 9, very present.
Present, sir.
And roll number 10, Tukaram, present. 4 are present as of now. If any more join in, just let me know later. Okay, so today for the next experiment, it will be implementation of SR flip-flop and D flip-flop. But we have not come for the theory of SR flip-flop and D flip-flop, so we'll not go for this as of now. Okay, because we'll let that theory get covered by in the next class. Okay, we'll have 2 lectures, so all flip-flops will be covered that time. So that's the time then we will go for flip-flop. Multiplexer, demultiplexer is already done. Okay, implementation of SR flip-flop and D flip-flop in the next practical we'll be doing it. So this practical, what we'll do is we will just finish off with that K maps. Okay, so we'll we will start off from where we stopped last class. Okay, so I'll just push it. I'll turn off the video because anyways it will not be clear.
Also, the C is same. C is 0 here, C is 0 here. So A and
Grammarly can help you write quickly and confidently, so you never have to
So-
slow down at
Sir,
Yeah, tell me. Hello? Hello?
so you're gonna show this YouTube video like throughout the practicals?
Now tell me.
So, like it will be easier because if you send us the link because it sort of keeps breaking in the middle.
Okay, no problem. The thing is, I'll be sending you all the updated link. Okay, this is just for a reference, Shravani. Okay, I'll be sending
Oh,
you.
okay, sir.
Yeah. Don't worry. I'll be making the updated videos of it and I'll be sending you all because there are still some errors. Okay, so I don't want to send you all with errors. So don't worry.
Oh, okay,
You will be getting the latest with HD quality. Don't worry about it. I
Okay,
know
sir.
it's cracking up, no? A bit.
Yeah.
Yeah, no problem. Okay, I'll be sending all that also very quickly. Yeah.
Okay, sir.
one to 0. Similarly, if you compare M2 and M6, you will find R and C same 1 0. Sorry, B and C same 1 0, but A is changing from 0 to 1. So adjacency also follows. This is called as the rolling of the map, or you can say that map rolling. Okay. So the adjacency follows between the two adjacent cells in this way and in this way, and also between the two end cells. Okay, in this way these two are same and these two are same. Not same means the two variables are same, one variable is changing. So this is all about the map formation. Now we will see why we do this, and we will see the reason by using this example. So let me make a k-map for 3 variable, and as you can see that in case of 3 variable we are having 8 cells. So first you make 8 cells, then you just make a line here. This shows that you are writing BC for this upper part and A for this part, A, BC. Now we will write the corresponding values for the cell, which is 0 0 0 1, then 1 1 1 0 and 0 1. You have to remember very important thing, that this is your MSB. A is your MSB and C is your LSB. You have to write ABC in this way, okay, MSB to LSB. You cannot change it. If you change it, then the values or the position of the cell is changed. Okay, so let's start filling it, but let me help you by writing here the min terms. This is M0, this is M1, this is M3, this is M2, M4, M5, then M6 here, and then M7. Okay, so let's fill it. You can see, let me change the color first. M0 is your 0, so you will fill 0 here, or generally it is kept unfilled. M1 is again 0, so 0 here. Now you can see M2 is 1, so 1 will be here, M3 is 0, and all the last 4 elements or cells are 1. Okay, so this is how we have to fill the k-map. Now the next step in the k-map is your pairing. You have to do the pairing of 2 ones, then 4 ones, then 8 ones, and then 16 ones. Okay, now the important question is how we can pair this. So let's see how we have to pair it. The most prior thing is to pair the 16 ones, but as we are having only 3 variables, there is not 16 cells, so at most we can pair 8 ones, but I cannot see 8 ones. We are having 1 2 3 4 5 ones, so we will move to the 4 ones, that we can pair 4 ones or not, and I can see that I can pair these 4 ones. Okay, remember you have to pair in this way or in this way. You cannot pair diagonally. Diagonal pair is not allowed in k-map, because in diagonal the adjacency does not follows. The adjacency is in the adjacent cells and in the last and the first cells, up and the down cell. In this way the diagonal pairing is not allowed, because in that way not only a single variable is changing, there are 2 variables changing. So this is our, let's say that give it as a name, this is our first pair. Now I cannot see any more pairs of 4 ones, but I can see the pair of 2 ones in this way. So this is our priority, and remember one thing, that the same one can be paired more than one time. For example, in this first I have paired this one, M6, and in this second also, let's say it is a second group of ones. In this second group of 1 I have again paired this one, so a single one can be paired more than once. Okay, So let's see what we have to do after pairing this. Once you have done your pairing in the priority that I have just told you, that priority 16, 18, 4, 2, then you have to just write it down as 1 plus 2. This 1 and 2 represents the group of ones called as implicants. We will see what is implicants, prime implicants, essential prime implicants. Now this one is what we have to see. You have to, now listen very carefully, you have to see the group of the ones that we just made and just find in that group what are the variables which are changing. So in this group I can see that A is 1, okay, it is not changing. A is 1 throughout, it is not changing from 1 to 0. So I will write A as it is. Now I have to see for B and C. In this first cell B is 0, in the second cell B is 0, no problem, but in the third cell B is changed from 0 to 1, so B is changing. So I will not write B because B will be 1 by this rule. By this rule B is 1, okay. Now I will see for C. In the first cell C is, for this cell M4, C is 0, and for M5 C is 1, so C is also changing. Similarly in the last two I can see that C is changed from 1 to 0, okay, and B is changed from 0 to 1. So B and C both are changing for this group of 1, that is 1. So I will not write B and C. In place of B and C I will write 1 1 plus. In second group of ones I can see that A is changing from 0 to 1, so A will be neglected, it is 1, but B and C is not changing. B is 1 and C is 0, so I will write it as B C bar. So F is simply A or B C bar, which is similar as compared to the result obtained from the Boolean algebra. I know it's little bit confusing for you, but in the next lecture we will do some good examples which will make it more clear. But actually there is a fact that when you have to understand from the basics, or you can say that very deeply, then at the beginning it's a little bit confusing, okay, as compared to the mugging up. But when you understood the whole concept, then it will be with you throughout your life. So that's why don't get frustrated out with this lecture. It's a bit tricky, you know. So if you don't understand it, play it once more or just move to the next lecture. In that I will elaborate it, or you can say put some examples which will elaborate the topic in a much more good way. Before that I will tell you one thing. For this second group of 1, the second group of 1 is equal to what? If I just write this ones without pairing these two ones, then what I am having, A is 0, so A bar, B is 1 and C is 0, so B C bar. Similarly for this one I am having A because A is 1 and B is same and C is same, so B C bar. So what I can do by using the Boolean algebra, I can see BC bar is common in both of them, so I will take BC bar as common, and then I'm left with A bar or A, and you already know A bar or A is what? 1, so I'm left with BC bar. Actually we are doing the Boolean algebra here, but without, you know, actually going to the steps involved in the Boolean algebra. We are doing the Boolean algebra. Boolean algebra is the basic thing that we just, you know, molded in the form which is much convenient to understand, or you can say that much easy to solve. So actually Boolean algebra is going in all these K-maps in this way that I have just told you, and this is the reason that we just change one variable between the two adjacent cells. Like in this case M2 and M6, only A is changing from 0 to 1. So that's why when this two cells is having 1, I can pair them up and just neglect the A in this way directly, that I have done here directly, because A is changing from 0 to 1, and if it is changing from 0 to 1, we are having A complement or A, that's why I can neglect it. So this is what actually goes inside the K-map. And in the next presentation, we will see some more example from the 2 and 3 variable K-map, and then we will move to the 4 and 5 variables K-map. So see you in the next presentation.
When you think of accounting and finance, what comes to mind? Don't worry.
In the last presentation, we completed the introduction about the K-map. We saw how it is beneficial to use the K-map in place of the Boolean algebra. We have actually seen a much elaborated description of the K-map, that how and why the adjacent cells must have only one variables changing, and it is very important for you to study that particular lecture first and then move to this lecture. And if you already know what is the K-map and how to solve it, then also I would recommend you to study that lecture first, then come to this examples part. So without wasting any time, let's move to our examples. So example number 1, I'm doing the example from the 3 variables first, which will help you understand the topic in a much better way. So we are having A, B, C as the 3 variables, summation of M 1, 3, 5, 7. Okay, so this representation is something familiar to you. We have already discussed when we were studying the SOP and the POS form. So if you don't know, then I will just give a small idea about it. This F represents your function. Okay, this A, B, C represents your variables. And remember one thing, that this order is very important. If A is written first, it means A is your MSB, most significant bit. And if C is written first, then it is your C is written last, then this is your LSB, the least significant bit. So this order is very important. While solving K-map also, I have told you that how to write the MSB and LSB. So don't change this order while writing your K-map. This summation of M represents that it is sum of product, and this 1, 3, 5, 7 are actually M1, M3, M5 and M7, and this tells us about the true values of this function f. So I believe that it is actually a truth table written in the short form. Okay, so let's move to the steps in solving this thing by using the K-map. The first thing that you have to do is to find out number of variables. Okay, so in our case we are having 3 variables, so small n is equal to 3, which are A, B, C. Okay, now the second thing is to find out the number of cells in your K-map. Find out number of cells in K-map. And how we are going to find it? It is actually the number of cells is actually the number of combinations in the truth table. So as you very well know that in case of 3 variable, the total number of combination is 2 to the power 3, which is actually 8. So we are going to make the K-map which involves 8 cells. So these are the two things that you first find from the given information. Then after we will move to make our K-map. So let's make the 8 cell K-map. Okay, 1 2 3 4 5 6 7 8. So total 8 cells are there. Now we will just write the variables A, B, C, MSB first, and at last the LSB. So writing the values 0 1 0 0 0 1, then 1 1 and 1 0. I have seen a common mistake that people used to write 0 1 then after 1 0. But as I have already told you that in the adjacent cells it is not allowed that we will change the two variables. Okay, if I put 1 0 here, then you can see that B is changing from 0 to 1 and also C is changing from 1 to 0. So you are changing the two variables in the adjacent cells. So if you pair them, you will not form this thing A or A bar, which is the soul of the K map, you can say. That's why we put 1 1, so that only B changes from 0 to 1, whereas C remains the same, 1 to 1. Fine. So you know that, okay, from the last lecture, right? So the next step is to fill out these things. So as this is the first example, I will write it down for you. This is your M0, this is your M1, this is your M2, this is your M3, M4, M5, M6, M7. This is just the initial lectures about the K-map. That's why I'm writing this min terms representing the cells. When you are familiar with this K-map and know how to solve it, there is no need to write this down. And then now next step is to fill out the values for which this function is true. So for M0, it's not true, so I will write it 0 here. For M1, it is true, so 1 here. M2, it is not true, so 0. For M3, it is 1. For M4, it is 0. For M5, it is 1. For M6, there is no 6 here, so it is 0. And for M7, it's 1. Now what we have to do next? We have to pair them up, and you already know what is the rule for the pairing. In case of 3 variable, the maximum possible pair of ones is 8, in which case all the cells are having ones.
Welcome to Python is Easy, your path to become a Pythoneer or Pythonista.
So you just pair them up and write the value as 1. Okay, because truth table is 1 for each and every possible combinations. Then the second thing, after 8 pairs of 1, we do is the pair of 4 ones. Okay, so we will find for the pair of 4 ones because we didn't have the pair of 8 ones, and I can see that I can pair these 4 ones with no problem. Okay, and as you can see that all the ones involved in this K-map is paired up by using this single combination of ones, which is called as your implicant. Okay, and I will give it name 1. Actually none of the other implicants, the group of ones, is involved, so this writing 1 is actually redundant, but we will stick to it. So this is the pair of ones that we just made. So the next step is to write the function. So f is what? Is equal to 1, and 1 is what? 1 is your the A is changing from 0 to 1. As you can see, the A is changing from 0 to 1, so we will neglect A. The B is also changing from 0 to 1, so we will neglect the B also, but the C is 1 throughout this group or the combination of the ones, so we will write 1 as C. So this is your answer, f is equal to C. You can see that these solving K-map is very simple as compared to your minimization using the Boolean algebra. Example. Okay, so let's take the second example as capital F. The variables are A, B, C is equal to summation of M 0, 1 to 4, 7. Okay, all the things are same. We are having 3 variables, so total possible combinations 8. So there are total 8 cells in the K-map. So it's same as the previous question. So without wasting any further time, we will just draw the 8 cell K-map. Okay, and you know how to write the variables: MSB first, then LSB last. 0 0 0 1 1 1, not 1 0, and at last 1 0. This is 0, this is 1. Okay, now in this example I'm not writing the M0 M1 M2 M3 M4 M5 M6 and M7 because you already know how to fill it. So let's see. For M0, this is 0 representing the M0, the value is true, so 1 is here. For 1 it's true, so 1 is here. For 2 it's true. For 3 it's not. And generally we don't write 0 because it makes our map messy. That's why we just write 1. For 4, yes, it is true. For 5 it's not. For 6 it's not. For 7 it is. Okay, so let's start the pairing. I cannot see that now. I will move to the pairs of 2 ones. Okay, so let's see how we are going to do it. This is the first pair. Okay, these 2 ones are now paired. To pair this one, I cannot see any other way other than pairing with this one. Okay, if there was 1 here, I would have paired this 2. If there was 1 here, I would have paired this 2, but there is only 1 here, so I have to pair it like this. Now this one, don't do mistake by pairing this in this way, like this. This is absolutely wrong because you are pairing the 2 diagonal ones, and we do not pair diagonally in K-map. I have already given the reason for it. So you cannot pair it also like this. So this one cannot be paired by or with the other ones. So I have to just pair it alone. Now we will move for this one. There is no one here or here, so I cannot pair it like this in this way. And now this one can only be paired in a way that I will just show you, like this and like this, because I have already told you that the adjacency follows in this way also, the first cell and the last cell, because you can see A is same in both the cells and also C is same 0 0 in both these cells, but B is changing, so only one variable is changing. That's why we can pair them up in this way. So let's give the name to it. This one is your first pair, it is your second pair, it is your third pair, and the last one is your fourth pair. Okay, now we will write the function. The function f is equal to 1 plus 2, this is actually or 3 or 4. Now we will find out 1 2 3 and 4. This one Okay, these two ones. I can see A is changing from 0 to 1, so I will neglect A, but B and C are not changing, they are 0 0. So I will write it as B complement C complement, or now we will see for 2. This is the second pair of the ones. In this, A is not changing, A is 0 throughout. So I will write it as A complement. And B is also not changing, B is 0 and 0. So B complement, but C is changing from 0 to 1. So I will neglect C. For the third, I can directly write it as A, B, C, because it is, for this cell, A is 1 and B, C are 1, 1 also. For the fourth one, I can see A is not changing, it's 0, so A bar, but B is changing from 0 to 1, whereas C is not changing, 0 0. So I will neglect B and write C as C complement. So this is the answer of this particular K map. So I think for this presentation, the two examples are sufficient. In the next presentation, we will solve some more examples and also see, if possible, the 4 variable K map. And I will tell you one thing, that how pairing reduces the number of variables. Okay, so see you in the next presentation. Okay, this example is f, the variables are a, b, c. Again, 8 cell K map, summation m 1 3 6 7. Okay, there are 3 variables, so 2 to the power 3 is 8, therefore 8 cell K map is involved. So we will make a 8 cell K map here. Okay, writing the MSB first and LSB last. 0 0 0 1 1 1 1 0 0 1. Okay, till now we have done almost everything that is required to solve a K map. Okay, we have seen why we write it as 0 1 then 1 1, not 1 0. It's already covered, so we'll not waste time in that. We'll just see some good examples and something new in each and every example. So in this example, if we start filling it out, so the 1 0 then 1 2 then 3 is there, 4 is not here, 5 is not, 6 yes, and 7. So these are the required positions for the 1. We are not writing 0 because it makes our map look messy. Now let's make the pairs of 1. So I cannot see that I can make a pair of 8 ones, but I can make the pair of 2 ones. So the first pair is this. This is the first pair. Then the second pair is this one. Okay, now you can see already all the 4 ones are paired, so no need to pair in this way again. But if you do it, let's do it and give it a name 3, then you will find out it is
शोका with the star है मैनेजर साहब. कैमरा शाय नहीं.
Redundant. How? We will write the function f 1 or 2 or 3. So f is 1 is what? 1 is this thing. The a remains the same, so a is 1 because a is not changing and it is 1. And also in this, b is not changing, it is 1, but c is changing from 1 to 0. So ab is for this 1. For 2, a is 0, so a complement, and b is changing from 0 to 1, but c is not changing, it's 1. So I will neglect b and write c. And for this 3, a is changing from 0 to 1, but b and c are not changing, and it is bc. Now you remember one trick that I have explained you in the Boolean algebra called as the redundancy theorem. And in that I explained you that when you are having three variables involved, and also each variable is repeated twice. Okay, the first thing is three variable involved, the second thing is each variable is repeated twice, and the third variable is, and the third case is, or you can say the third condition for this theorem is one variable is complemented. Okay, and if it is like, then we will take the complemented variable and neglect the variables other than it. So I can see that three variables involved, a, b, c. Each variable is repeated twice, either in a complemented or a normal form. A is repeated twice, b is repeated twice, and c is repeated twice. Now I can also see that only a is complemented, whereas b and c are in uncomplemented form. So I will take this 2 and neglect this one. F is equal to ab or a complement c. And this bc is what? It is something that we are getting from this third group of 1. So it's already redundant. We can prove from the redundancy theorem. And redundancy theorem is nothing but it comes from the K-map actually. Okay. And if you want to make a truth table, you can verify from there that there is no role of BC. It's making something 1 which is already 1. So we can neglect it because this one and this one is already paired in this first group of 1 and this second group of 1. So this is something that you should keep in your mind while solving the K-map. You just do not do the things which are redundant in the pairing. Okay. So this was the first example in this lecture. Now we will move to our second example. And the second example is function f with variables a, b, c is equal to summation m 0, 1, 5, 6, 7. So again you can see that 3 variable is involved. So we have to make a 8 cell K map. Okay. Now we will write the variables a, b, c, MSB first, LSB last, and the values of this variable.
हेलो बच्चों, तो क्या आप 2021 जेई के एग्जाम के लिए ड्रॉप लेने का सोच रहे हो?
Or you can say that the combination, different combination of this variable. Now we will fill the map 0, 1, M1 is there, so 1, 2, 3, 5, 6, 7, 4, 5, 6, 7. Okay, now we will start pairing them. The first pair is for these 2 ones because this one cannot be combined in other way. Similarly, this one can also not be combined in another way other than this. Now we are left with this one. There are two possibilities to combine this one. The first one, let's do it in different color. The first one is this, okay, and the second one with this one, okay. So there are two ways to combine this particular one, and let's see what we get, the function, what is the result by considering these two cases. So f is, let's say this is 1, this combination is 2, this is your first implicant, this is your second implicant, this one is your third implicant, this one is your third implicant, dash, okay. So for case 1 we are having 1 plus 2 plus 3. So 1 is what? A, and B, A and B. Similarly, 2 is A complement, and C is changing from 0 to 1, and B is not changing, so we are having B complement. And the 3 is your A, B is changing from 0 to 1, so we are left with C. So this is what we are having for the case 1. Now let's see for case 2. The function f is 1 or 2 or 3 dash. 1 and 2 will be the same, but 3 is now changed. In this we are having A has changed from 1 to 0, so we will neglect A, and B is B bar and C is C. So you can see that both of these are minimum, both of these are reduced to a same extent, but they are not same. So I can write one conclusion in the K map. You can write it as a note that the result is minimum, okay, but can not be, but may, this is not can, this is may, but may not be the same, or you can say unique. Okay, so this is one important point that you should keep in your mind, that I have just shown here by solving this particular function. Okay, so this was the few special cases in your K map that you should keep in your mind while solving the question. Now in the next lecture we will see what is the meaning of the implicants, prime implicants and essential prime implicants, how to find this from a K map. So see you in the next presentation.
What do you mean by public speaking? These are two different words, by the way, public and speaking. Let's understand one by one. Public.
In this presentation, we will see some examples of K-map with 4 variables. We have already done the example
Which was you close your mic.
of the K-map with 3 variables. Actually, we have started our K-map with the 3 variables. Now we will move to the 4 variables. So this is our first example. The function f with 4 variables a, b, c, d is equal to summation small m 0, 2, 3, 7, 11, 13, 14 and 15. So this is the question, and you have to minimize it. Okay, so let's start solving it. Now, as you can see, there are 4 variables involved, A, B, C, D. So it's very obvious that we are having 16 possible combinations, and each combination is represented by one cell in your K map. Okay, so for 16 combinations, there are 16 cells. This is your MSB, A is your MSB, and D is your LSB. Okay, and this is your M0, or let me write it in different way. From this I can write as M0 is your 1, M2 is 1, M3 is also 1, M7 is 1, M11, M13, M14 and M15 are all 1. Okay, you know this representation very well. Now we will move to our K map. So first we will draw a 16 cell K map. Zero, 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 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0.
Have you guys heard of Opera GX browser? Probably. Opera GX browser is one of the world's first.
And this cell is your M0, this cell is your M1, this cell is your M2, this cell M3. Similarly, I will write down all the cells: M4, M5, M6, M7. Now don't do a common mistake by writing M8 here, because this cell, this particular cell is what? 1, 1, 0, 0. 1, 1, 0, 0. So this is 8, 4, 0, 0. 8 plus 4 is 12. So this is for 12, not for 8. Okay, so this is for 12, not for 8. For 8, this cell is there, 1, 0, 0, 0. This is 8, this is M9, M10, M11, M12, M13, M14 and M15. Okay, I have just written the min terms that represents the cells depending upon these values of A, B, C, D. Each cell is having its corresponding values of A, B, C, D. Like this cell is 0, 0, 0, 1, 0, 0, 0, 1, M1. That represents the 1. Similarly, all the other cells. Now we will fill this map by the given information, which is already given in the question. So I have written it in this form. You can directly fill it by here. So for M0, M2, M3, M7, M11, M13, M14 and M15, the values are 1. So I'm just filling them. One, 1, 1, 4 is 0, 5 is 0, 6 is 0, 7 is 1, 8 is 0, 9 is 0, 10 is 0, 11 is 1, 12 is 0, 13 is 1, 14 is 1 and 15 is 1. Okay, so we have filled all the ones. Now we will start pairing them, and I'm just rubbing this main terms written here so that the pairing is clearly visible. Okay. Now let's start pairing them. As we know that in 16 cell K-map, the best possible pairing is what? 16 ones. That gives you 1. But in this case, we don't have such conditions. So we will move for the 8 ones, but here we cannot find, or we are not getting 8 ones to pair. So we'll move for 4 ones, and I can see this combination of ones, these 4 ones can be combined, and let us give it name 1. Now we will see how to combine this one. It can be combined like this way, these 2 ones. Now we are left with these 2 ones. This is your 1101 and this is your 1110. The only way to combine this one is by combining with this one, and this one can be combined like this. So we can find that all the ones in this K-map are now combined, or we have paired them. Now this time also we will give them the name. This is 2, this is 3, this is 4. Now we will write down the function. Function f is equal to 1, the first prime implicant plus the second prime implicant plus the third prime implicant plus the fourth prime implicant. Now the 1 is equal to CD, because CD is not changing in this group, whereas A and B are changing from 0 to 1 and 1 to 0 for this 4 combination of the 1. You also remember when you combine 2 ones, 1 literal is reduced. When you combine 4 ones, 2 literal is reduced. Similarly, when you combine 8 ones, 3 literal is reduced, and when you combine 16 ones, 4 literal is reduced. In this, you can see that we have combined the 4 ones, and there are in total 4 variables. So by combining 4 ones, the 2 literals is reduced, and that 2 literals are AB. So we are left with CD. Okay. Now we will see for the second prime implicant, this one, and this one. In this, A, B is same, so A bar, B bar, and out of C and D, you can see that C is changing from 0 to 1, whereas D is same, 0, 0. So it should be D bar. So we are done with 1, 2. Now we will see for the third prime implicant, this one. In this also, AB is same, whereas D is changing from 1 to 0, and C is also same. So we'll neglect D and write C. So we are done with the third prime implicant also. Now we'll move to the fourth prime implicant. In this, AB are 1, 1, and it is not changing, so AB. C is changing from 0 to 1 while D is 1. So we'll neglect C and write D. So this is the reduced form of the function that we have just obtained from the K-map, and most probably you now know how to draw a 16 cell K-map for the 4 variable and fill the values in the K-map which is given in the question, and then pair them up and then write it in the reduced form. The one important thing that we saw in this lecture is this, that while combining the two ones we are getting off from the 1 literal, and when we combine 4 ones the 2 literal is reduced, and we have already seen in this case the first prime implicants case. Similarly, if I see for the second prime implicant case, which is this one, we have combined 2 ones, okay, and by combining 2 ones we are just off from the 1 literal, and that literal is C. Okay, so this is a very common thing that you should keep in your mind, and in the next presentation we will see another example of the 16 cell K-map that is for 4 variables. So see you in the next presentation. So the first thing is to see how many variables are involved. So there are 4 variables involved, and for the 4 variables we are having 16 cell K-map. So we will make the 16 cell K-map first. Okay, A is your MSB and D is your LSB. This cell represents your M0, this one represents your M1. Similarly, I'm writing down the representation of the cells at the extreme right corner: 5, 6, 7, now 8, 9, 10, 11, 12, 13, 14 and 15. Now we will fill the cells. For 0 the function is high, so 1, there is no 1 here, so for this min term M1 the function is low or 0. So I usually don't write 0 in the K-map because it makes my map messy. I just write 1. For 2 and 3 it is 1, so 2 and 3 it is 1. 5, 7, 8 it is 1. 5, 7, 8, 10, 11, 14, 10, 11, 14 and 15. Now the next step is to pair them. So let's start pairing. The largest pair that I can see is the pair of these 4 ones. Okay. Now after this, you can pair these 4 ones, this one, and these 2 ones. So this is your second prime implicant. This one was your first prime implicant. Now we are left with this one and this one. So I can combine this one in this way. This is our third prime implicant. You can see that these 3 ones are already combined, but to combine this one, I just took it again. So you can do it a number of times you want, but avoid redundancy that I have explained you in the example when we were solving the 3 variable K-map. So avoid redundancy, but also form the largest possible group of ones. Now we are only left with this one, and it can be simply combined like this. There is no other way to combine this one. Okay, it can only be combined with this one. So this is our fourth prime implicant. Okay, 1, 2, 3, 4. Okay, now we will write down the function f, which is equal to 1 or 2 or 3 or 4. Your 1 is CD, because CD is not changing and AB is changing. And also you just combine the 4 ones, and by combining the 4 ones, 2 literal goes off. The second one, or you can say the second group of prime implicant, these 4 ones, we can see that A is changing from 0 to 1, but B is not changing, it is 0. So we will write B complement. Whereas in C and D, you can see that C is changing from 0 to 1, but D is not changing, it is D complement. So B complement, and D complement is what we get from this second group of ones. And in this also we combine 4 ones, so we are out of, or we just neglected or reduced, you can say, not neglected, reduced the 2 literals, that is A and C. Now we will move to the third group of 1, which also contains 4 ones. So in this also we will reduce 2 variables, and let's see what are these variables. So I can see that B is changing from 0 to 1. Okay, 0 to 1, but A is not changing, it's 1. So A is there, and in this I can see that D is changing from 1 to 0, but C is same. So C is here. Now for fourth, you can simply write it as A complement B and D. And in this we just combine 2 ones, so we just reduced the 1 literal, that is C. So this is the answer of this K-map, and it's very simple to find the reduced form of a function by using a K-map as compared to the Boolean algebra. Now what happens if there is a K-map in which all the 16 cells contains a 1, or what happens if a K-map having 8 cells like this, and all the 8 cells have ones. So you just combine them, and you can see that you just combine the 8 ones, and by combination of 8 ones we know that we reduce 3 variables. Okay, or I can say that the 3 variables are gone, and in case of 8 cell K map, the all we have is a 3 variable. So we have at last, by reducing this all a b c to the ones, we are left with 1, because a is now 1, b is now 1, and c is now 1. So at last we are going to get 1. So whenever such type of situation happens, the answer is 1. Now in the next presentation we will see something about the don't care conditions in the K map. After that we will study about the 5 variable K map. Y, Z and W is there, and the min terms are 157, 157, 9, 11, 13, 9, 11, 13 and 15. So here we are having the min terms as M1, M5, M7, M9, M11, M13 and M15. Now we have to reduce this by using the K-map. We can do it by the Boolean algebra also, but by doing this with K-map will save lots of time. So as there are 4 variables involved, 2 to the power 4 is 16, so we need a 16 cell K-map. Let's make it. It takes a bit time to make a 16 cell K map. Okay, so we are done with it. Now the MSB is written here X, Y, Z, and the LSB here W. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay, now we will fill these cells by the information given here about the min terms. So M1 is high, M5 is high, so 0, 1, 2, 3, 4, 5, and M7 is high, 5, 6, 7, M9 is high, 8, 9, 10, 11, 11 is high, 12, 13, 14, 15. So we have filled our ones in the corresponding cells. Now this is time to make the pairs. So let's see what we can do. I can make the pair of these 4 ones, and we will give it a name quad, QUAD, quad 1. Okay, similarly to pair these 2 ones, I can again make a pair of these 4 ones, because you have to make the pair of the largest, and we will give it name quad 2. Now this one is left, and it is the only one which is left. So what we can do, I can make pair of this thing. Let me change the color. This one is good. I can make the pair of these 4 ones to include this one, and we will give it name quad 3. So actually in this example we are having the 4 pairs of 1, 3 pairs of 1, not pairs, we can say, we will say quad, 3 quads of 1, and we can write the function now, the function f. It is equal to quad 1 plus quad 2, this is or quad 3. So the quad 1 is what? The y is changing from 1 to 0, but x is not changing. So x. Similarly, z is changing from 0 to 1, and w is same, which is 1. So w plus quad 2 is y is same, 1, and these two columns are same as the previous, so we'll write w as it is, yw. And quad 3, and this xy are changing from 0 to 1, but z and w are not changing, and z is 0 and w is 1, so I can write z bar and w. So this is your answer, this is your function, which is the reduced form. Okay, if we have followed the Boolean algebra, then it would have taken several steps, and we can do it in a very short time, and it took time to explain you actually these things. So once you have the practice to do these things, you can do it very fast. So this is all in this lecture. We solved the example of a 4-variable K-map, and I think the 4-variable K-map is now completed. If you feel any doubt, you can ask in the comment box. I'll try to clear it down. And in the next presentation, we will see the don't care, which is very important thing. We'll see how to use the don't care, how to clear it in case of max terms and min terms both in 8 variables. 8 variables, not in 8 cells and 16 cells K-map both. So see you in the next presentation. In this presentation, we will see the use of don't care to reduce the function in a much minimum form. So if you are following my lectures, then definitely you have heard about this word care. We use this thing, or this thing appeared when we were in the codes, when I was telling you about the BCD code. Okay, so if you don't know, then you can see that lecture. But let's move to this example, and actually before moving to this example, let me explain a little bit about this don't care. So don't care is something you can say a state which is actually not mattered in a certain operation. For example, if you are giving a signal to an aircraft for its launch or for its landing, and only the hands are required, only you require your hands. For example, this is you, this is your hands, and this is your legs. Okay, and only these hands are required to give the signal to the aircraft. The position of your leg is of no use. Okay, they are not going to see your legs, so this thing is like don't care. You can put your legs any way you want to, but you cannot put your hands any way you want to, because you have to signal it. So your legs are like don't care. So we will see how to use this don't care along with this compulsory conditions or the min terms, which is representing your function, to reduce your function to a much minimum form. Okay, so before wasting any time, let's see this example. In this, there is a 3-variable function f, which is having the min terms m2, m3, m4, and m5. Now this particular thing represents the don't care. Summation d. This d represents the don't care. Instead of d, you could have phi. Okay, this is sometime used instead of D. And 6, 7 is the cells in which we are having the don't cares. Okay, which means M6 and M7 are the don't care conditions. So let's first make our 8 cell K map. Three variables are A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Okay, so M2, M3, M4 and M5, let's fill it. 0, 1, 2, 3, 4, 5, and our 6 and 7 cell is the don't care. So we will write cross, or you can write D as well, but in most of the books you will find it cross, so I'm using the cross notation for your don't care. So this is your K map. This is how it looks. Now we have to reduce it. So if you are not having this don't care, then what is the combination? So this was the first combination that you would have made in case you are don't having the don't cares. Then the other group, the other pair you can say, is this one, and these two pairs can easily be minimized. But now you are having the don't care. So this don't care, this D, could be 1 or it could be 0 as well, as it is don't care. We can take it as 1, we can take it as 0, whatever you want to. But we take it as 1 in case we have to reduce our K map by using the minterms. And we take it as 0 in case we have to reduce our K map or reduce our function by using the max term. So keep this thing in your mind. This is when you are operating with minterms, and this is when you are operating with max term. Because what we want out of the K map, we want the greatest possible group of the ones which are 2, 4, 8, 16 and so on, and we want it to be the largest. We have learned already about the prime implicants. Okay, implicant is the group of 1, prime is the largest group of 1. So we wanted the largest. So what if I change this cross with 1? So let's do it here. Let me make the another map for you. This is A, B, C. So this was your 1. I'm just writing this again in this map, but in this map I'm going to change this cross by 1. Why? Because this is the don't care and I can take it as 0 or 1. And now in this particular example I'm minimizing my function f by using the K map, and in that K map I'm using the minterms, and I have already explained you that in case of minterms we are going to take the don't care as 1. So I took the don't care as 1. Now let's do the pairing, or let's make the combinations or group of ones again. Now I'm not going to combine these two ones in this way like I did here, but I'm going to combine it like this way. Now it's not a pair, we have just made it a quad. Okay, the group of 4 ones. Similarly, I am not going to combine these two ones like this way, but I will do it in this way. So instead of having the pairs, the two pairs, I'm having the two quads. Okay, this is your quad 1, this is your quad 2. And as I have told you, when you do the pairing, when you are having the group of two ones, you eliminate the one variable. When you are having the group of four ones, you eliminate the two variable, and so on. So in this case, you are having something like, from this you would have either AB, BC, or CA in complemented or the normal form. But now you are having the only single literal odd with the other one. Let's see how. For example, first let me write the function from this K-map. In this, we are having A bar, and the C is changing from 1 to 0, so C is neglected, and B is written as B because it is 1. Now, or A and B is 0, C is changing from 0 to 1, so B bar. So A bar B or A B bar. This is actually your A X or B. So you can see that this thing. And now I'm going to write the function from this K-map. So this is 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So let's write it for the quad 1. And this A is changing. You can see this quad 1. And this A is changing from 0 to 1. But your B is not changing. It is 1, and C is changing from 1 to 0. So wow, we have just A reduced, and also the C is eliminated. We just made A and C as 1. So we are left with B. Okay. If you don't know the basic of the K-map, then you may refer my earlier lectures on this K-map series. So don't get confused here. It's a very basic thing. We have actually moved on these things. So this don't care is actually the last part that you have to study in the K-map. So we are going to reduce this, write this quad 2. In this quad 2, you can see that B and C both are changing from 0 to 1. So they are 1, and A is 1, and it's not changing. So I will write it as A. So you can see that the same function can be written as A XOR B, which is A complement B or AB complement. In this, you can see extra literal in every what you can say in every ANDed operation. But here you are having A or B. Only a single OR gate is required. But here AND gate is required, then another AND gate is required, and then OR gate is required. So 3 gates are required, but here only single 2 input OR gate is required. So this is the advantage of using the don't care as 1 in case of min terms grouping, and 0 in case of max term groupings. So I think it is now clear to you what the don't care is and how we have to use it. If you feel any problem, then please ask it in the comment box. I will try to make another video, another example with 4 variables. If you have any doubt on it. So that's all for this presentation. Solve the 2, 3, and 4 variable K-map in which don't care is also involved. Now in this presentation we are going to cover another part of your K-map, which is K-map using max term. Basically in this presentation we are not going to group the ones, but we are going to group the zeros. This is sometimes very good to solve the problems. Let's see how. So let me take the first example. in this presentation. And in this example, a 8-cell K-map is given to you. Okay, and the variables are A, B, C. A is your max term, C is your min term. 0, 0, 1, 1, 1, 1, 0, 0, 1. Okay. Now the entries are 0, 0, 0 and 1, 1, 1. Okay. So this is the 8-cell K-map given to you, and you have to find the function f by using these zeros. Till now what we were doing, we were grouping these ones. So if I group this one, I will make this group which involves the 4 ones. This is our prime implicant, and the next group will be this one. And you know how to reduce them and write them as your function f. But now in this presentation we are not going to group the ones, but we are going to group these 3 zeros. Okay, so let's see how we can group them. The first group that we can make is this one. We will give it name 1. And the second group we can make is this one, in which also there are 2 zeros. So this is all that we can do in this. We cannot group these 3 zeros because we know that the group can be of 2 zeros or 2 ones, 4 zeros or 4 ones, and so on. So the function f is equal to 1 plus 2. But remember one thing which is very important is that in this type of K-map, when you are grouping the zeros, the function should be complement, because the value of the function or the value of the output f is false. What are the zeros and ones we are filling in this cell? These are the values of your f, that is your output. When we group the ones, it is true, so we just write f with no complement sign. But when we group zeros, we have to give a complement sign here, that is bar or dash. So this is a common mistake that students do, so just keep it in your mind that you have to write it as f complement. Okay, now let's write what is the value of 1. It is A is not changing in the first group, so I will write as A complement because A is 0. B is also not changing, is 0 here, and again it's 0, so I will write it as B complement. And you can see that C is changing from 0 to 1, so we are not going to write C in this one. Okay, similarly in 2, A is A bar, and you can see that B is changing from 0 to 1, so B is not written here, and C is 1, so C. And on the left hand side you are having F complement. Now we will use De Morgan's law. De Morgan's law, and we will take complement of the both side. We'll take complement of the both sides, so this thing will become F complement, and again its complement, and the complement of whole right hand side. You know F complement and then its complement is F, and by using De Morgan's law, I hope you know what is De Morgan's law. We have completed it in the earlier lectures. So this is something we are going to get after applying the De Morgan's law. Now we have to use De Morgan's law again for this one and this one. So it will give us A. This AND operator will change to OR, and this complement B will be B. Okay, and this A complement will be A, the AND will change to OR, and the C will change to C complement. And this is your F. So as you can remember, this thing is your POS form. This is product of the sums. There are two sums, A, B, A, C complement, and we are writing it as a product. Actually, this is the name given, but actually there is nothing like the sum and nothing like the product. It's just a representation. It looked like our mathematical sum and then its product, but actually it's OR operator and this is AND operator. So this is how we can get our function by using the zeros, and this is called as K-map using maxterm. Now, if I simplify this by using the Boolean algebra, then you might be knowing what is the distributive law. I'm directly using it, distributive law. So by using the distributive law, it is A or B C complement, and this is something you are going to get when you combine this one. So let's do that. The function f, now I am writing it as f, not as f complement like here, because I am combining the ones. So for this one, let's say this is 1, this is 2. For this one, it is A simply because both B and C are changing, and for this 2 we are having BC complement because A is changing in this group from 1 to 0. So you can see that these two things are same. So there is no problem whatever combination you make by using zeros or by using ones. But sometimes it's very helpful when you combine the zeros. As you can see here, we have to make the combination of the 3 zeros. We have to combine the 3 zeros, but here we have to combine 5 ones. However, the both things are simple, but when you are having a K-map having the 16 cells, and let's say we are having 15 ones in it and 1 0, then you can simply write a 0. Okay, so we will see some more example on this K-map using maxterm in the next presentation, which will make it more clear to you, and I hope you got what it is in this presentation only. So thanks for watching, and see you in the next presentation. In the last presentation, we saw one example by using the zeros, by grouping the zeros, which we called as the K-map by using the maxterm. Now this is the next presentation in which we will solve the example number 2, in which we are given a function f having the variables a, b, c and d, and the min 1, 3, 4, 5, 9, 11, 14, 15. So this is the question given to you, and in this question we will first try to find out the maxterms, and then we will fill the K-map and try to group the zeros and find the final answer. So let's move to its solution. If you have studied from my lectures the algebra, then most probably you might remember that we used this type of problem in which there was the min term given to you, and by using this information we calculated or found our maxterm. So we will use the same thing, in which your f function is represented as the maxterm, and for the representation of the maxterm we use pi with capital M. This summation with the small m represents your min term, and this pi with capital M obtained by the ones when the function function is 1 in your truth table, and max terms are obtained when the function f is 0 in your truth table. So actually these values 1, 3, 4, 5, 9, 11, 14 and 15 are representing that the function f is 1 for m1, m3, m4 up to m15. So you clearly know that for what values this function f is 0. It's actually 0 for the terms which are not involved in this main term. So we can see that 0 is not involved, so it is 0 for m0. It is 0 for 2 because 2 is also not involved in this. 4, 5, 6 is not there, 7 is not there, 8 is not there, 9 is there, 10 is not there, so 10 will be included in this max term. 11, 12, 13, 12, 13, 14, 15. Okay, fine. So this is something that we can obtain from this information. Now we will make the truth table. And as you can see that there are 4 variables involved. So 2 to the power 4 is equal to 16, which means that there are total 16 combinations possible, and we require 16 cells in your K map to represent each of these combinations. So for 4 variable, you very well know that we require a 16 cell K map. So let's make it. If you want to try it by your own, you can pause the video and solve this problem, because you already know how to do it. We just did a problem in the last presentation. I hope you will do it without making any mistake. Till then, I will make my 16 cell K map. Okay, so now it's completed. Let's write down the variables A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Fine. Now this is time to fill up these cells. Okay, so as the topic is K-map using the max term, I'm going to fill this cell by zeros. I'm not going to fill this cell by using the ones. So at 0, this is your M0. It is 0, so I'll fill 0. 1, 2, 2 is 0. 3, 4, 5, 6, 6 is 0. 7, 7 also 0. 8, 9, 10, 11, 12, 13. Okay, and 14, 15 are 1, so it should be kept vacant so that the map should not look messy. So we have filled our zeros. It looks fine. Now this is time to group these zeros, and you know that we have to make the groupings of zeros 2, 4, 8, 16, and the priority is increasing in this way. So we have to see for the 16 zeros, which is of course not in this K map. We have to look for 8 zeros that I cannot find in this K map. Then we have to see for 4 zeros, and of course I can see these 4 zeros, and I can combine it in this way. Okay, and I will give it name 1. Let's change the color for the next group. After this, I'm not having any combination of the 4 zeros anymore, so I'll look for the 2 zeros, and you can see that this 0 and this 0 can easily be combined in this way. Let's give it name 2, and we'll change the color for the next group. And this is our next group. Let's give it name 3. So all the zeros are now combined, and this time to write the function f. And as you know that this function is written here for zeros, so it should be f complement. So write f complement is equal to 1 or 2 or 3. Okay, so the first one, the first group of zeros gives us, let's see what, the a is changing from 1 to 0, so this should not be included. B is 0 and it's not changing, so we'll write B complement. Let's see for C and D. The C is changing from 0 to 1, okay, but D is not changing and it's 0, so we'll write D complement. Similarly for the second group, A complement B, because A, B is same, and you can see that D is changing from 1 to 0. And C is 1, so we'll write C here. Similarly for the third group, we are having A, B, C bar, and this is for F complement. Now we want F, so we will use the De Morgan's law. We will complement the both side, and you are very good in complementing the things, so I'm going to write this thing directly. It is B or D and A or B complement or C complement and A complement or B complement or C. Okay, so this is your answer. Now you might be thinking that we have to do an extra practice of the De Morgan's law to get our answer, but right now I'm going to tell you something that will keep you away from this De Morgan's law, particularly in this problem. That is, writing this answer directly. So let's see how we can do it. We will just change the values of the variables what it is right now in the groups. Let's see how. For example, I'm taking this second group, this one. In this, I found A as 0, B as 1, and D was changing from 1 to 0, so it should not be included, but C is 1. So I was having A complement B C, that I have already written here. But what we will do now, we will do two things. We will write any variable, if it is 0, we'll write it as A instead of writing as A complement, which means the low is considered to be high and high is considered to be low, and also this AND operation is considered to be OR. Okay, so let's see how we can do. In the first group, you can see that A is changing from 1 to 0, so it is not included, but B is 0. So I'm not going to write B as B complement because it is 0, but I will write it as B. And I'm not going to use this AND operator, but I'm going to use this OR operator. And in C and D, you can easily see that C is changing from 0 to 1, but D is not changing and it is 0. But I'm not going to write D as D complement, but I will write it as D because it is 0. So you can see that we just found the first part of our answer, B or D. Similarly, I will do for the rest of the things and I will find this easily. We are not doing anything extra. We are just using the De Morgan's law right here. We are just assuming 0 as 1 and 1 as 0, and we are changing the AND with OR and OR with AND. Here there was OR, but we are using and here we are having AND, we are using OR. So this is what we do in our complement, or you can say in our De Morgan's law. Instead of doing an extra step, we are just writing it down because we don't have that much of time in examinations. So I hope it was interesting to you and you got how to solve this K-map by using the maxterm, and also in the second last lecture we completed our K-map by using the don't cares. Now the only thing left in the K-map is the 5 variable K-map that we will see in the next presentation, and also the previous year questions in the competitive exams that we will also see in the coming time. So thanks for watching. See you. Presentation we will solve the examples from the competitive exams, which will help you a lot in understanding the key concepts much more. So without wasting any time, let's move to this 5 variable K-map. A 5 variable K-map looks something like this. Actually, every time when you have to solve the 5 variable K-map, you need not require to make this structure because it's quite complicated to make, but we will see how to solve it. So let's say we are having a function f, and as there is a 5 variable involved, let's give it name a, b, c, d and e. These are our 5 variables. Fine. And if I make the truth table of this 5 variable, so as there are 5 variables, 2 to the power 5 gives us 32. So total 32 possible combinations of A, B, C, D and E. So it would look something like 0, 0, 0, and this is total 16 terms. B is 0, 0, 0 and 0. This is 1, and this will be 1, 1, 1, 1. Similarly, the next one, when A is 1 and all the other terms B, C, D will repeat again. One, one, one. This is the next 16. So in total there are 32 cells required in the K-map, and as you can see, this is your 4 variable K-map, and then again a 4 variable K-map, and 16 plus 16 cells give you 32 cells. So it's not now a planar map, 2-dimensional map you can say, but now it is a 3-dimensional map. So let's see how we can solve this 3-dimensional map. Let's say this map is for A is equal to 0, which means A complement, and this one is for A, because for the first 16 combinations A is 0. So if I keep A as 0 for this map, I can simply write down B, C, D, E as I used to do. Wait a minute. As I used to do in a 4 variable K-map. So this will be your B, C, D, E. Similarly, in this map, when A is 1, I can write down this combination. This is actually a 4-variable combination in a 4-variable K map. So B, C, D, E. Okay, now this is a 5-variable K map, and I explained you how it is arranged. For the first map, the A is 0 or A complement. For the second map, A is 1, and rest of the things will remain same, which means this cell coincides with this cell. Similarly, if I take this cell, it coincides with this cell. Okay, they are overlapping each other, they are same to each other. Only difference is that the A is changed from 0 to 1. Okay, now let's see how to solve a problem in this type of K map. So I'm going to fill this map randomly. This is your 1. It's hard to write in it. This is your 1. Let's change the color. 1, then 1. One here, one. Let me first fill the map, then I will explain how to do it. And in this map, we are having 1 over here, okay. I think it's done now. So let's start grouping. So as you can see, this one are same. Here 1 and 1 is there, 1, 1, 1 and 1. So in the both maps, on the extreme corners there is 1. So I can group these ones in this way. This is our first group, and I can write function f as in this first group. If I see, then A is changing from 0 to 1. Here A is 1, and in this map A is 0. So A is changing from 0 to 1. So A is not written here. Now we will see for BCDE. It's very simple. You can do it like you did in your 4-variable K map. Okay, so before that, I will write this thing which will help you: 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. So if I see BC, then C is not changing, 0, and B is changing from 0 1. So I will write C complement. Okay, and in DE, D is changing from 0 to 1, but E is same, which is 0. So E complement. Okay, so this is for first one, first group. Now we will do the combination of the other group, which involves 8 or 4 ones. So you can see that I can do a grouping of these 4 ones and also these 4 ones. So in total, I combined 1, 2, 3, 4, 5, 6, 7, 8, 8 ones. Okay, and when we combine 8 1, the 3 variables go off, and the first variable which goes off is a, because a is changing from 0 to 1. Okay, so a is neglected. And now we will see for b, c, d, e. B is not changing and it's 1, so b. C is changing from 1 to 0, neglected. Similarly, in D, E, D is not changing and it's 1, so D, and E is changing from 1 to 0. Okay, so we are left with this 4 ones, this one, this one, this one, and this one. Let's combine them. How we can do it? I can do a combination of these 4 ones. Sorry. These 4 ones. But you can see that this combination is not present in this map. So it means A is not changing from 0 to 1. So we have to consider A as a complement because it is present in the complement map of A. So I will write A complement, and this is your 1 1. BC is changing from 0 to 1, DE is 1 1, so A complement DE. Now let's group these 2 ones, this one and this one, and I can group them like this way. Okay, not this way. We can make the group of these 2 ones, this 2 and this 2. Fine. So A is changing from 0 to 1, so we are not going to write A, and we can see that BC is 1 1 for this group, and D is 0 to 1, so we are not going to write D also, and E is 1. So this is your answer, and this is how we have to solve the 5 variable K map. It's a bit lengthy, a bit complicated, also complicated to explain you. I did what I could do to explain this 5 variable K map. This is a better view to understand, a 3D view to understand this 5 variable K map. But if you are asked in the question, then you have to make it in this way. First, you make the 4 variable K map. Okay, make it 4 variable K map. Assign A as 0 for this particular 4 variable K map, and then make another 4 variable K map in which A is 1, and just write B, C, D, E as we did in a 4 variable K map, and then combine the ones. But you must have a good imagination, and at the same time you must have a good practice to do the combination in this 2-dimensional 5 variable K map. I just explained this one in this way because it makes you feel that what actually is going inside this 5 variable K map. Once you are done with this, you know how it is done. You can definitely do by using this map, this map also. So this is all for this 5 variable K map. In the next presentation, we will solve some examples from the DRDO and ISRO.
Okay, guys. Hello.
Yes, sir.
Yeah. This K map was a very important topic. I said I'll take it up on the practical, but anyways, we did not go on flip flops. So I said we'll cover up K maps here. I will send you all also the updated one on YouTube. Okay, so you all can go through it. Guys, I just have taken your attendance. Just see if I have left out anyone. Okay. Roll number 2 present. Roll number 3 present. Roll number 6 present. Roll number 7 present. Roll number 8 present. Roll number 9 present. Roll number 10 present. Roll number 12 and 13 present. Rather than that, all absent. Okay, guys. Chalo. You'll take care now. I'll meet you all
Thank you,
for the
sir.
next. Most welcome. Bye bye.
Thank you, sir. Bye bye.
Thank you. Bye bye.